Yes, dear students, let us discuss some problems in dynamics today. Yes, dynamics. In the dynamics, let us see the problem number 1 or question number 1. Let us see that question number 1. What is that question? A bag of mass M, capital M was given, hangs by a long thread, and a bullet of mass M comes horizontally with a velocity V, gets caught in the bag. That means embedded in the bag. Then for the combined system, if you see the options, momentum and kinetic energy were given, and we have to find momentum and kinetic energy. Let us see how to solve the problem. Now in this let us draw a diagram. Say from a rigid support, a long thread you take, some bag, this is a bag, this bag is of mass M, is hanging like this. Now there is a bullet, say this is a bullet, this bullet is given of mass small m, and it is fired horizontally with a velocity v. This is the velocity v. Now it is getting embedded, and the combined system, because of the impact, when the bullet collides with the bag, due to the impact, the combined system will rise to some height like this. Now bag and bullet gets embedded and it rises to a height. If you take the center of the system, this is the center. When the bullet collides with the bag, due to the impact, the bullet gets embedded inside the bag and both together move with some velocity. Now we have to calculate kinetic energy and momentum. So we have to calculate what is the velocity of the combined system, bullet and bag. For this, we have to use law of conservation of linear momentum. So in this conservation of linear momentum, whenever two bodies collide, we can write total momentum before collision is equal to total momentum after collision. And before collision, if you see the standard formula, m1u1 plus m2u2 is equal to m1v1 plus m2v2. Here u1 is v and u2 is 0. Bag is at rest before collision. After collision, both together are moving with a velocity v prime. Therefore, if you substitute this bullet mass, you can take m1, this mass you can take m2. Therefore, m into v plus, as the bag is at rest before collision, we can write m into 0 is equal to, here m both together are moving with same velocity, so mv prime. Then if you calculate mv is equal to v prime, if I calculate m plus m, so v prime is equal to mv by m plus m. This is the combined velocity. Then what is the momentum, combined momentum? If you calculate momentum, momentum is mass into velocity. Mass into velocity is m plus m into v prime, that is m plus m into v prime is mv by m plus m. So m plus m gets cancelled. The momentum, combined momentum will be what? mv. But here combined momentum options are wrong. Therefore, it cannot be momentum. Then we have to verify the options. Kinetic energy. What is kinetic energy? Kinetic energy is half mv square. Kinetic energy is equal to half. Here both together are moving. Therefore, total mass of the system m plus m, and together they are moving with a velocity v prime. So v prime square if you take and substitute this v prime value here, half m plus m into v prime is mv by m plus m whole square. This if you simplify, m plus m, this is m square v square by m plus m whole square. So this m plus m and square gets cancelled. Then here you are going to get m square v square by 2 into m plus m. You are going to get, this is the kinetic energy of the combined mass of the system. And therefore, if you verify the options, the fourth option, kinetic energy, is m square v square by 2 into m plus m. Therefore, fourth option will be the correct option for this question. Now let us discuss the problem number 2. See that problem. If you see, there is a diagram in that problem. The surfaces are smooth. Acceleration of the block, there are two blocks. One is on the table and one is hanging from a pulley, and the acceleration of that block m2 you require. and this is a very important problem. Let us see how to solve this problem. Let us draw the diagram. There is a smooth table, so friction is absent here. That point you have to remember. And there is a block. This block is of mass m1 given, and now here there is a pulley attached, and now it is connected by a thread, and that thread is passed over the pulley, and here one more pulley is there like this, and now a thread is connected, the passing over this pulley, same thread, and it is connected to a rigid support, and now from this pulley a block is of mass m2 is hanging like this. This is the diagram given. From this we want to find the acceleration of this block. Let us examine this diagram and solve the problem. Many steps are involved, so you have to follow the problem very carefully. Here, first point, there are two strings. This is string 1. This point you have to remember, and this is string 2. And remember, whenever strings are given, length of the string remains constant. This is one of the constraints that you have to remember. So string 1 and string 2. Now here, to solve the problem, let us say as this m2 is moving down, acceleration of m2 say a2, and acceleration of m1 say a1. m1 is moving horizontally on the surface, and m2 is moving down with an acceleration a2. Now we have to find this acceleration a2. This is the question, and there are two strings. This is a1. Then how do you solve? Here again one more pulley is there. This is a pulley which is movable. This pulley is fixed, whereas this pulley is what? Movable. Let us say that pulley as what? P. Now what are the constraints equations you have to write? Whatever, whether the pulley is moving down and this is moving forward, length of the string remains constant. Therefore here the constraint is length of the strings remains constant. Now how do you find length of the strings? To find length of the strings, let us follow a diagram like this. All these distances, this plane you divide this into x and y. All distances in the horizontal direction I denote with x. All distances in the vertical direction I denote with y. Now this mass, suppose you take a reference line. Let us take this as the reference line and say an observer is standing at the reference line. Because this length is fixed, it will not change even when the bodies are moving. Therefore I take this as the reference line. If you observe from this reference line, what is your observation? This mass is moving towards the observer. This mass is moving away from the observer. Let at an instant of time, this mass is at what distance? Say it is at a distance x1. And from here, this pulley is moving and this mass is also moving. So let us take from here this distance as yp. P stands for pulley. And this block is at what distance? This block is at a distance, I take it as y2. So this, as these are the distances are along y-axis, these distances I denote with y2, and for pulley I denote with yp. This mass I denote with as first mass x1. Like that you have to denote the distances from the reference line, from this observer. And now when you keep the bodies, leave the bodies free, this body is moving down, this body is moving towards the observer. That means x1 changes, and this y2 also what happens? Changes. Now what is the relation between these two to calculate? Now let us take the length of this string as L1 and the length of this string as L2. Whether x1 may change, yp may change, y2 may change, but L1 and L2 remains constant. Then how do you write L1? L1 means up to here I take the distance, from here to here it is x1. As this distance, this length remains constant, this distance will be yp, this distance will be yp. Therefore I can write x1 plus yp is equal to L1. So I can write x1 plus 2yp is equal to L1. This is the length of the string. As the bodies are moving, x1 will change, yp will change. Therefore to get the velocity and acceleration, let us differentiate with respect to t. If you differentiate with respect to t, we know velocity is equal to ds by dt, dx by dt. So this is velocity of this body and this is velocity of the pulley. As L1 is constant, it will be 0. Again, to get acceleration, you differentiate for second time. This will be a1 plus this is ap. ap is acceleration of the pulley is equal to 0. Therefore, I can write a1 is equal to minus 2ap. This is equation 1 that you are going to get from the constraint of the first string. In the same way, if you write length of the string L2, how do you write the length of the string L2? L2 I can write from here to here, the total distance is y2. And if to get L2, this pulley distance we have to subtract. So this distance minus this distance yp is equal to L2. Similarly, again to get accelerations, as you know the distance, you have to differentiate twice. Then you will get v2 minus vp is equal to 0. You are getting velocities. Again, if you differentiate a2 minus ap is equal to 0, that means a2 is equal to ap you are going to get. That means as both are connected by the same string, with what acceleration pulley moves down, with the same acceleration this block M2 also what happens, moves down. Therefore, A2 is equal to AP, you are going to get this equation 2. Now if you observe equation 1 and equation 2, what you are going to get? A1 is equal to minus 2AP, this is equation 3. AP plus if you substitute A2, A1 is equal to minus 2A2. Minus indicate, so you got A1 is equal to minus 2A2. Minus indicates directions. As M1 is moving in the forward direction, M2 is moving downwards. That means they are moving in different directions. Minus indicate magnitudes we have to take. A1 is equal to 2A2, that you are going to get. Now from this A2 you have to calculate. To calculate A2, now here we have to see the tensions and the forces that are acting on different bodies. Let us start with pulley. Let us draw a free body diagram. Free body diagram for pulley, if you write, this is the pulley. It was held by two strings and a string is hanging like this, and now here a tension T2 will act like this along the string, because at the end of this a block M2 is hanging, so its weight is hanging down. Therefore, tension T2 will be acting, and if you take these two sides, in this tension T1 will act like this, because this is completely one string. You know, for an ideal string, when the pulley is frictionless, tension along the string remains what? Same. Therefore, here tension, here also tension remains same. From this you can write T2 is equal to 2T1. This is one more equation that you have to remember. T2 is equal to 2T1. Next, one more free body diagram you have to draw. Free body diagram for M2 if you draw. And if you take M2, M2 is hanging like this. This is mass M2. Then its weight M2G acts downwards, as you know, as acceleration is directed downwards A2, and here a tension T2 is acting on M2 in the upward direction. So the free body diagram is this for M2. Then if you equate, as it is moving down, definitely you can say M2G must be more than T2. Therefore, M2G minus T2 is equal to M2A2. This is the acceleration equation. Next, one more equation that you are going to get. And similarly, if you draw free body diagram for M1, free body diagram for M1, if you take M1, M1 is on a horizontal surface and it is pulled like this with a tension T1, because here I am showing you the tension T1, same tension will act here also. So along this string, a tension, I can show you here, this is tension T1, this is tension T1, this is tension T1, this is tension T1, here tension T2 will be there, T2, M2G will be acting downwards. This is all, if you incorporate in the diagram, it will become very clumsy. That is why I am showing you separately. Now same tension will act like this tension T1 and this tension T1, and it is moving down in this, because two strings are there, the accelerations of the two bodies will be different. As we already said, acceleration is A1, we can write m1 a1 is equal to t1. So you have different equations, t2 is equal to 2t1, m2g minus t2 is equal to m2a2, m1 a1 is equal to t1, and you have this equation a1 is minus 2a2. So if you say this is equation 4 and this is equation 5 and this is equation 6. So we have drawn free body diagram for the pulley, for this body, we got different equations. We used constraint equation, then we got a1 is equal to 2a2. So using these equations, this and this, we can get the acceleration of this block m2. So how to solve these equations? Let us see. Now let us take equation 5. m2g minus t2 is there. t2 is what? 2t1. So 2t1 is equal to m2a2. And now here we have to eliminate t1. But if you see equation 6, t1 was given as m1 a1. So that if you write m2g minus 2, t1 you substitute here, then it becomes m1 a1 is equal to m2 a2. So these, by using these two equations, we have written, we eliminated t2 here, and then in place of t2 t1 you got, t1 place we have written m1 a1 from equation 6. But finally what do you want? Acceleration of this block m2 you want. Acceleration of the block m2 means a2 I require. How do I get a2? a1 I have to eliminate. How do you eliminate a1? See, by using constraints of length, I obtained one equation, a1 is equal to minus 2a2. Now in this place a1, because I want a2, a1 I have to eliminate. So in this place a1, substitute the value 2a2. So you can write m2g2 minus 2m1. Only we have to take magnitude. Minus indicates direction, that you have to remember. So a1 is equal to 2a2 you are going to get. 2a2 is equal to m2a2. So now if you see this equation, you got only term a2. Now simplify this. m2g minus 2 into 2, 4, m1 a2 is equal to m2 a2. But you want a2. So take this term to the other side. m2 a2 plus 4 m1 a2. Now you want a2. Take a2 common. m2 plus 4 m1. This is all simple mathematical simplification that you can do on your own. Then you further simplify. I want acceleration a2. a2 is m2g by m2 plus 4m1. So you are going to get acceleration a2 as m2g by m2 plus 4m1. See the options. First option m2g by 4m1 plus m2 you are going to get. So first option is your correct option. In the same problem you can remember one more point. Suppose if I want acceleration of the block m1, here I am calculating acceleration of the hanging block. Suppose if I want acceleration of the block on the horizontal surface, if you have to calculate, when you know a2, substitute a2 here, you can also get a1. This if like that it is asked. Otherwise in this problem the acceleration is, first option is the correct option. So that is your correct answer. Now let us see the next problem. Problem number 3, or you can say question number 3. And what is that question? If you see, two billiard balls of same size and same mass are in contact on a billiard table. A third ball of same size and mass strikes them symmetrically and remains at rest after impact. Then the coefficient of restitution between the balls you have to calculate. Let us see how to solve this problem. First let us draw a diagram. There is a billiard table. Imagine two billiard balls of same size and mass are in contact on a billiard table. Suppose say there is a billiard table. On that billiard table this is a ball of mass, this is another ball. Say both are of same size and same mass. This is m, this is m. Both are at rest. These two are at rest, remember. Now what is happening? Along the common tangent, if you take, this is the common tangent that you have for both the balls. This you can draw common tangent. There is another ball coming from some, this is another ball. Remember, all balls same size and same mass. And what is given? A third ball of same size and same mass symmetrically. It is moving, say, with some velocity u, it is moving. It is moving symmetrically and comes to collide with these two balls. Along the common tangent is coming like this and colliding with this. After collision what happens? these two move, but this is coming into rest. That you have to remember. This is the situation before collision. Then after collision, what happens? This ball is coming to rest. This is coming to rest. But these two balls, this is colliding with them symmetrically like this. That means it is moving in this direction with a velocity v. This is moving in this direction with a velocity say v. This is coming into rest. This is the situation after collision. Now, in this entire episode, we want to calculate what is the coefficient of restitution between the balls. See here, they are in contact. Let us redraw the diagram like this. This is the center of the ball. When they collide, this part, if you draw the diagram neatly, you are going to get an equilateral triangle here. That part I will magnify like this. This is velocity v, this is velocity v, this is the direction of motion, common tangent direction CT, and here you are going to get an equilateral triangle. This is the center of the first ball, this is the center of the second, this is the center of the third. Here if you take, then this angle will be 60, this angle will be 60, this angle will be 60, because it is an equilateral triangle. Then if you take, this angle will be 30 degrees, you will get, this angle will be 30 degrees, you are going to get. Now, to find coefficient of restitution, what is the formula for coefficient of restitution? You know that formula, V2 minus V1 by U1 minus U2, whereas relative velocity of separation by relative velocity of approach. Now you have to calculate V2 V1, U1 U2. Let us see how to calculate. As this velocity is V, it is moving in this direction. Its component in this direction will become common tangent direction V cos 30. This component also in this direction becomes V cos 30. So after collision, the velocities are what? V cos 30, V cos 30. Components of velocity you have to take. Then first step, let us use law of conservation of linear momentum. Law of conservation of linear momentum. If you use along common tangent direction, total momentum before collision is equal to total momentum after collision. In a short form, I can write like this. Then before collision, this body is at rest. This body is moving with a velocity u, plus these two bodies are at rest, so their velocity is 0. Only this is moving. After collision, this body which is moving with a velocity u is coming to rest. Therefore, 0 plus the component of velocity in this direction is mv cos 30 plus component of this body velocity in this direction is mv cos 30. If you use law of conservation of linear momentum, you are going to get like this. Then mu is equal to, I can write as 2mv cos 30. Therefore, m and m gets cancelled. So here mu is equal to 2mv cos 30. Now m and m gets cancelled. U 2v cos 30 is root 3 by 2. So 2 and 2 gets cancelled. U is equal to v root 3. So v is equal to u by root 3. So this is the velocity after collision. This is the first step. Now to find E, we have to go for the second step. Let us take the second step. E is equal to, in this E, I said V2 minus V1 by U1 minus U2. V2 and V1 are velocities after collision, U1 and U2 are velocities before collision. What is velocity V2 after collision? The velocity V2 along common normal direction you have to take. Already you got u by root 3 minus, this is coming to rest 0 divided by, here U1 and U2. U1 is velocity before collision. Before collision, this is only moving. And what is its velocity in common normal direction? Component u cos 30 minus these two before collision are at rest. Therefore, u2 term becomes 0. Therefore, u is u by root 3 by u cos 30 root 3 by 2. You simplify, u and u gets cancelled. Therefore, you will get 2 by root 3 into root 3. So u is 2 by 3. So coefficient of restitution between either these two spheres or balls or these two balls will be 2 by 3. So the option is 3. 3 is the correct answer. Let us discuss the next problem, problem number 4. That problem is, a ball is dropped from a height h above a floor. Coefficient of restitution between the floor and the ball was given. The ball will rise to what height after first rebounds? How to solve this problem? Let us see. There is a floor. Here the point that you have to remember is, floor is fixed. So before collision and after collision, it is always at rest. This point you have to remember, always at rest. So take this as second body, because for collision you require two bodies. This I will take it as second body. Let us take a first body. This ball is taken as first body and it is dropped from some height, and that height was given height h. Then it collided with the ground with some velocity. Let us take that velocity as u1. From kinematic equations, you know, whenever a ball is dropped, a body is dropped from some height, the velocity is given by root 2gh. So u1 is equal to root 2gh. First body is colliding with the second body. I said second body is at rest, so u2 is 0. Now after the ball colliding with the floor, floor cannot move because it is fixed. The ball will again rise up along the same line, but for our convenience I take that in a separate line. If the ball will rise to a height, say h1 in the first bounce. Actually it happens along the same line, but for our understanding I am drawing this line separately. I am showing to this height h1. Every time the height gradually what happens? Decreases. It is rising to a height h1. After collision also, v2 velocity of second body is 0. Velocity of the first body v1 will be, whenever it rises to a height h1, from kinematic equations you can write its velocity is root 2g h1 because it is rising to a height h1. Then what is coefficient of restitution formula? You know, v2 minus v1 by u1 minus u2. So what is v2? Floor is fixed at rest 0 minus of what is v1? Velocity of the rebounding body root 2g h1, but here first it is moving downwards and now it is moving upwards. So this velocity I can write minus root 2g h1. As it is a vector, direction of velocity is changing. Downward direction if I take positive, upward direction will become what? Negative. As direction is changing, this I can write minus root 2g h1 by u1. It is striking the ground with a velocity root 2g h minus u2 is 0. This if you simplify, minus of minus plus root 2g h1 by root 2g h you are getting. So this you further simplify, root h1 by h. So e square is equal to, h1 by h, but you want in the first bounce what is the height? h1 you want. So h1 is equal to e square h. So this is the answer. Fourth option is the correct answer. So fourth is the correct answer. But in this problem, you can do the problem like this also, or you can remember a formula. In nth bounce, as you know, again it falls down, rises up, falls down, rises up. This takes place a number of times. Finally it comes to rest. Then you can derive a formula in the same way. In the nth bounce, e power 2nh, where h is the initial height of fall. By remembering this directly, you can solve this problem, where n is the number of bounces, and here first bounce was given. So here given n is equal to 1. So h1 is equal to 2 into 1h. So h1 is equal to e square h. By directly remembering this formula, you can do this problem, or by taking the formula for e, substituting u1 v1, u2 v2, you can solve. In either of the way you can solve the problem. The answer is e square h. Fourth option is the correct answer. Now let us see the next problem, problem number 5. And if see this problem, particle of mass m and velocity v collide elastically with a stationary particle of mass m. One is moving with a velocity v and another is at rest. and here you have to see the collision is two-dimensional and the collision is elastic. These are all the points you have to remember. The angle between the velocity vectors of the particles after collision is actually a conceptual question. You have to remember forever, and here the points that you have to note down is collision is elastic. So this you have to highlight, and it is a two-dimensional collision. Now keeping these 2 points in mind, let us see solve the problem. This is a particle of mass m. It is moving with a velocity say v. Before collision we call it as velocity u1. So u1 is equal to v. It is colliding with another particle at rest. This particle is at rest. If suppose it is a one-dimensional collision, after collision both will move along the same line. But here it is a two-dimensional collision. Therefore this is the situation before collision, and after collision what happens? This is the line of motion, but they are moving in different directions because it is a two-dimensional collision. Say, let us say the first body is moving in this direction with a velocity v1, and the second body is moving in this direction with a velocity v2, then that collision will be a two-dimensional collision. And what is the angle between them? If you take the angle between them, this angle is say theta. Actually here we have to prove what is that angle. We have to show what is that angle. Say these two are moving in different directions at an angle theta, we have to find the value of theta. So to solve the problem, because it is an elastic collision, the points you have to remember: momentum is conserved, and kinetic energy is conserved. So these 2 points you have to remember, and both concepts you have to use. Let us say momentum conserved. Momentum conserved means total momentum before collision is equal to total momentum after collision. Before collision, the momentum is mu is equal to, say it is moving in this direction, and as this angle we do not know, let us say mu bar. In the vector form, let us take after collision mv1 bar plus mv2 bar, because the velocities of the first body was m1, velocity of second body v2, velocity of first body is v1, velocity of second body is v2. So take into the vector form, mu bar is m1 v1 bar plus mv2 bar. In this, mass gets cancelled, so you can write u bar is v1 bar plus v2 bar. You are going to get u bar. Now by using parallelogram law, v1 and v2 are at an angle theta. Then how do you write u? U is equal to, you can write v1 square plus v2 square plus 2v1 v2 cos theta. You can write this sum of two vectors by parallelogram law. You can write this. So keep the result here. Next concept, let us use Ke is conserved, because it is an elastic collision. Ke is conserved. Ke is conserved means total Ke before collision is equal to, you can write total Ke after collision. So total Ke before collision means, how do you write? Because this is only moving, total Ke before collision is half mu square plus this is at rest, so its kinetic energy 0. And afterwards, as kinetic energy is a scalar quantity, we do not use vector notation here. Here we, because momentum is vector, I used vector notation here because I do not know this angle. I cannot simply add these two. That is why I have taken vector form and I added vectorially. This point you have to remember. And now coming to this point, after collision, m v1 square, as masses are same, half m v2 square you have written. So total Ke before collision is equal to total Ke after collision. Before collision half m u square, as it is at rest 0. After collision, we have to write half m v1 square, half m v2 square. As kinetic energy is scalar, we should not use vector notation. Here I used vector notation because momentum is vector and I have to add, because they are not moving in the same direction, they are moving in different directions. I have to add them vectorially. That is why I have used vector notation here. But here you should not use. That point you have to remember. Now further, if you simplify, half m gets cancelled, then you are going to get u square is equal to v1 square plus v2 square. Now you have two equations. These two equations if you club, you will get the answer. Here u square, but already u value I got. So what is u value? Root of v1 square plus v2 square plus 2v1 v2 cos theta. If you square it and write, what you are going to get? v1 square plus v2 square plus 2v1 v2 cos theta is equal to, here what you are having, v1 square plus v2 square, because u square. So this v1 square plus v2 square gets cancelled on both sides. So you are going to get 2v1 v2 cos theta 0. As 2v1 v2 cannot be 0, cos theta is 0. That implies theta is what? 90 degrees. Therefore, these two fly off at an angle of 90 degrees with each other. That you have to remember. So option is 3. Correct answer is 90 degrees. 3 is the correct answer. Now let us see the next problem, problem number 6. Let us see that problem. That problem is given, a particle is projected with a velocity of 10 meters per second in a direction at 15 degrees with the ground. Particle strikes against a vertical wall whose plane is perpendicular to the plane of its path at a distance 2 meters from its point of projection. After that impinge, the particle returns to its point of projection. Diagram was clearly given. Then what is the coefficient of restitution between the particle and the wall? Let us see how to solve this problem. Let us draw the diagram. There is a wall like this, and from here at a distance of 2 meters as given, there is a point. A ball was thrown at 10 meters per second. Say speed is u, let us take, at an angle of some 15 degrees was given. This theta is say some 15 degrees. Now naturally this ball will trace a parabolic path and strike the wall like this. Again, what is given in the problem? It is taking a path OAB. Let us take as given in the diagram. From there, it is coming back to the same point like this, along the path BCO. This is the diagram given. Then here the ball is coming in contact with the wall. The ball is coming in contact. So here I want to calculate the coefficient of restitution. So coefficient of restitution is, already we discussed, E is equal to V2 minus V1 by U1 minus U2. So you want velocities before and after collision. Let us see what are those velocities before and after collision. You know, for a projectile, whenever it is thrown at certain angle, you can resolve them into two components. The component of velocity in this direction is u cos theta. The component of velocity in this direction is u sin theta. Now, after the ball collide with the wall, this is the wall. Remember, wall is fixed. Fixed means before and after collision, it will be at rest. This is the point you have to remember. Only ball is rebounding back. Ball will move back. So, wall I take it as second body. I take wall as what? Second body. Second body velocity before collision V1 0, after collision V2 0. First body I denote with U1 U2, second body I denote with V1 V2. So, before collision it is U2, not V1. Before collision U2, second body. After collision V2. These two are 0, you have to remember, because it is at rest. Now, in this, when the ball collide with the wall, only horizontal component of velocity changes, but vertical component of velocity remains what? Same. After collision, the ball is rebounding back like this. Between the ball and the wall, this is ball. Ball I take it as first body. Wall I am taking it as second body. Because of collision, it is rebounding and coming back to the same point. But the vertical component of velocity, what happens? Remains the same. So, since vertical component remains the same, vertical component of velocity remains same, I can write time of flight is 2u sin theta by g. Time of flight of the particle, because it is going and coming back. So the total time is what? Time of flight. Time of flight will remain same. That can be taken as 2u sin theta by g. Now let us calculate this time of flight here also. It is going from OAB and coming back from BCO. Let us calculate the times. To calculate the time, how do you get the time? Time is equal to distance by velocity. Because distance is equal to velocity into time, time is equal to distance by velocity. So what is the time taken to go from OAB to OAB in this direction? It has to travel a distance, say this distance I will take it as d, as it is given 2 meters, I will substitute later d by, in that direction what is the velocity? U cos theta is the velocity in that direction. This is equation 1. Now again it is coming back from B to O along the path BCO. So time taken for BCO is equal to, it is covering the same distance, but in that direction I want the velocity. How do you get that velocity? That velocity I take it as what? Say U prime. If you know U prime, you can calculate this velocity. How do you get that U prime? For that we have to take the formula E is equal to V2 minus V1 by U1 minus U2. What is V2? Wall is at rest, so V2 0 minus V1. V1 is velocity of the first body. Velocity of the first body is the ball is colliding and moving back. This velocity I take it as U prime. So this I can write minus U prime because the direction is changing by U1. What is the velocity of the body before collision? Velocity of the body before collision is U cos theta. This body is colliding with the wall. Before collision it is U cos theta, but the wall is at rest. Wall is U2 0. Therefore, if I take and simplify, EU cos theta is equal to U prime you are going to get. Therefore, this time BCO you get D by EU cos theta. This is equation 2. So you got TOAB and TBCO. What is the total time taken? Let us take T is equal to TOAB plus TBCO. And we got total time as 2u sin theta by g is equal to TOAB you got D by U cos theta plus BCO you got D by EU cos theta. Because time of flight remains the same from this equation, and you got, as you are calling it as 1, let us say this equation has 2, this equation has 3. From 1 to 3 you can write T is equal to this. So let us simplify this. 2u sin theta by g is equal to, if I take D by U cos theta common, 1 plus 1 by E you are getting, and further you simplify u into u square 2 sin theta cos theta by g is equal to d into 1 plus 1 by E you are getting. But I want to calculate coefficient of restitution in that E. So how do you get this? This I can write u square sin 2 theta by dg I can write 1 plus 1 by E. Now substitute the values, you will get the answer. U square sin, because 2 sin theta cos theta is sin 2 theta. What is u given? 10. So 10 into 10 into sin 2 theta, sin 2 into 15 degrees as the angle is given, by d was given 2. It is at a distance of 2 meter, and acceleration due to gravity, if you take it as 10, is equal to 1 plus 1 by E you are getting. If you further simplify, 10 and 10 gets cancelled. 2 how many times? 5 times. So 5 into sin 30 is what? Half. So half is 1 plus 1 by E. So now this I can write 5 by 2 is equal to 1 plus 1 by E. So 5 by 2 minus 1 is 1 by E. 5 by 2 minus 1 is 3 by 2 is 1 by E. So E is equal to 2 by 3. So the coefficient of restitution in this case you are going to get 2 by 3. See the options. Second option is given 2 by 3. So answer is 2. Now let us discuss the next question, that is question number 7. and that question is given like this: the first ball of mass m moving with a velocity u collides head on, that point you have to remember, with second ball of mass at rest. The coefficient of restitution is given, then the ratio of speed of the first and second ball after collision you have to calculate. Then how to solve this problem? Let us draw a diagram. Say this is a ball of mass m, it is moving with a velocity say u. Now actually the first body velocity we call it as u1, say it is u. Second one is at rest, u2, but mass is same m. But because it is a head-on collision, after collision also they move in the same direction. This move with a velocity v1, this move with a velocity v2. v1 was not given, v2 was not given, but you want to calculate the ratio of speed of the first and second. v1 is velocity of first ball, v2 is velocity of second ball. We want to calculate v1 by v2 is how much. Here two unknowns are there, and to solve this problem two equations are required. So what are those two equations and how to solve this problem? So v1 and v2 are the velocities of the first and second body after collision. We want the ratio of v1 by v2 as per the problem. So here two things we have to calculate. How to calculate those two things? Let us see. In the first point, coefficient of restitution is given. So since E is given, the collision is, you have to decide this first. Collision is inelastic. It is an inelastic collision, and moreover in this 2 points you have to solve. At least you require 2 equations. How to get those 2 equations? Let us see first one. Because it is inelastic, we know in any collision momentum is conserved surely. Therefore use law of conservation of linear momentum. We know total momentum before collision is equal to total momentum after collision. Before collision mu plus 0 is equal to, after collision m1 m2 v2. So as masses are same, velocities are v1 and v2, and this if you simplify m gets cancelled. So u is equal to v1 plus v2 you are getting. Equation 1. In this v1 you want, v2 you want. So to solve one more equation is required. Because E is given and the collision is inelastic, we know by definition E is equal to v2 minus v1 by u1 minus u2. So how do you write this? v2 minus v1, because they are in the same direction, you can write v2 minus v1. u1 is u minus u2, second body is at rest. So from this I can write v2 minus v1 is equal to EU, equation 2. So equation 1 and equation 2 if you solve, you will get that ratio. Let us solve that. Write both equations at one place. v1 plus v2 is u, and here v2 minus v1 is EU. If you add these two equations, v1 gets cancelled. So 2v2 is equal to, if you add u, you take common 1 plus e. So v2 is equal to u into 1 plus e by 2 you are going to get. This v2 you substitute in any one of the equations. You get v1 as u into 1 minus e by 2. Now you want the ratio of speed of the first ball v1 by speed of the second ball v2. v1 by v2 is equal to u into 1 minus e by 2 by u into 1 plus e by 2. If you take u by 2 gets cancelled. The ratio you get 1 minus e by 1 plus e. Therefore the answer is 1 minus e by 1 plus e. Option 1 is the correct answer. So that is the answer. This way you can solve this problem. Okay, now let us see the next question, question number 8. That is, a sphere of mass m is moving horizontally with a velocity v0, collide against a pendulum bob of mass m at rest as shown in the figure. You follow the figure carefully. The masses stick together after collision. Then what is the maximum height attained by the composite system? Let us take, this is a bob hanging like this, mass m given because they are of same mass, and another mass m is moving with a velocity v0. Now this is at rest. This comes and collides. Because of the impact, both stick together and they move to some height above the ground. Now you want to calculate what is this height. Because of the impact they are raising to some height. So to know the height, what is the velocity that you have to calculate? Because of the impact, this will impart some velocity on this body and you must know that velocity. If you know that velocity, height you can calculate. You know the formula h is equal to v square by 2g in kinematics. So to get the height you require v. What is the common velocity of these two bodies? For that, because it is a collision, any collision momentum is conserved. This is coming and colliding with this. So in this collision momentum is conserved. So use law of conservation of linear momentum. If you use law of conservation of linear momentum, as you know, total momentum before collision is equal to total momentum after collision. Before collision it is moving with a velocity mv0 plus this is at rest. Now after collision both stick together and they are moving together with some velocity. So mv plus mv, both stick together and moving with some velocity, mv plus mv. Therefore if you solve, mv0 is equal to 2mv. So mv0 is equal to 2mv. If you simplify, m and m gets cancelled. So the velocity will be v0 by 2. Both together are moving with a velocity v0 by 2. Now with this velocity, this is the velocity given because of the impact. They are raising to a height h. As I already gave you, h is equal to v square by 2g. If you write h is equal to v square and v0 by 2 square by 2g, and this becomes v0 square by 4 2g. So this will be v0 square by 8g. So the height they attain is v0 square by 8g. If you see the options, fourth option is given v0 square by 8g. So fourth option is the correct answer. Let us see the next problem, that is problem number 9, or you say question number 9. In that, a ball is released from a height h, 500 meters. It falls under gravity and hits a floor. Coefficient of restitution was given. The ball has successive collisions with floor till it comes to rest, and total time taken by the ball till it stops, rebounded from the floor. This you have to calculate. If you see this problem, there is a floor is at rest, a ball is dropped from some height. That height is given 500 meters as it is given in the problem. Then it rebounds, again falls, again rebounds, again falls, rebounds. Like that slowly it comes to rest. Then what is the total time? Here there is a formula for total time taken. That formula directly you have to remember, that total time taken is equal to TD. First to hit the floor, it has to fall from maximum height to the floor. This is called time of descent. TD into 1 plus E by 1 minus E. This is the formula, direct formula. This you have to remember. In this, what is TD? Where TD is equal to, from kinematics you can write root 2h by g. So the total time will become root 2h by g into 1 plus E by 1 minus E. This is the formula you have to remember. From this if you calculate, root 2 into height was given 500 meters, by g you take 10 into 1 plus, as coefficient of restitution was given as 0.2 by 1 minus 0.2. Simplify, 0 and 0 gets cancelled. 50 into 200, root 100 is 10 into 1.2 by, this is 0.8. This if you further simplify, 10 into, this decimal and decimal gets cancelled. 4 if you cancel, here 3 4s you get, 2 4s you get. Again further if you simplify, 5 into 3, so it takes 15 seconds to come to rest. So the answer is third. So third option is the correct answer. So here you have to remember this formula directly instead of deriving this formula. Now coming to the 10th question. In this, rubber ball drops from a height h, and after rebounding twice from the ground, it rises to a height h by 2. What is the coefficient of restitution? This problem already we dealt. It's an extension of that problem. It is falling from some height. First it rebounds and rises to some height h1, again falls from there and rebounds to a height h2. Like in every bounce, height gradually what happens? Decreases. Now here rebounding twice, height you have to calculate. Here also you have to remember a general formula. Like suppose n bounces takes place, then there is a formula in the nth bounce, that is hn is e power 2nh. This is the formula. Now in this problem, number of bounces n is equal to 2. Initially it is falling from a height h, therefore, but in the second bounce it is rising to a height h by 2. This is given. This is given. And in this problem you have to calculate coefficient of restitution. So substitute in this, h by 2 is equal to e power 2 into 2 into h. So h and h gets cancelled. 1 by 2 is equal to e power 4. So coefficient of restitution is half whole power 1 by 4 is the value of coefficient of restitution. So the answer is 3, as third option was given as half whole power 1 by 4. So 3 is the correct answer. Now let us discuss the next problem, that is problem number 11, or you can say question number 11. This is a very important problem, please follow it carefully. A ball of mass m hits a floor with a speed v making an angle theta with a normal, and the coefficient of restitution is given. Find the speed of the reflected ball, and it is a two-dimensional collision. Let us see how to solve this problem. There is a floor and this is the normal drawn to the floor. A ball is thrown with a velocity v at an angle theta. Now after colliding with the floor, the ball gets reflected and we want to find what is its velocity after reflection. Now here it is colliding at an angle theta, but it is rebounding. At what angle, that we do not know. So say that angle as what? Alpha. Now coefficient of restitution is given. What is coefficient of restitution? V2 minus V1 by U1 minus U2 along common normal you have to take, remember. So this is common normal and this is common tangent. Whenever collisions are given between one body and another body, common tangent and common normal you have to take. As it is a two-dimensional collision, we have to resolve velocities into components. How do you resolve? Let us see. If you extend this, I can take this as origin. This will be x-axis and this will be y-axis. Now this can be taken as negative y-axis, and the initial direction of the ball is like this with a velocity v. This is initial direction and this angle is theta, this angle also theta. Then this can be resolved into two components. This component will become v cos theta, this component will become v sin theta. Like that, whenever there is a two-dimensional collision, you have to resolve the velocities into components. Next, it is reflecting and moving in this direction with a velocity v at an angle alpha as we have assumed. And now again this you resolved into two components. This component will become v prime cos alpha and this component will become v prime sin alpha. So these components are along common tangent direction, these components are along common normal direction. Now here, to solve the problem, what we have to do is apply law of conservation of linear momentum along common tangent direction. That means total momentum before collision is equal to total momentum after collision. Here also you have to remember this is fixed. So before collision and after collision its velocity will be what? 0. So before collision I take it as u2, after collision I take it as v2 is 0. Therefore total momentum before collision along common tangent direction, if you take, mass is what? Ball of mass m, moving with a velocity in this direction, initially v sin theta, and after collision, before collision this is at rest, so that velocity I am not taking. After collision also this is at rest, only ball is moving, so in that direction I can take m v prime sin alpha. Therefore here m and m gets cancelled, you get v sin theta is equal to v prime sin alpha. This is equation 1. Here also there are two unknowns. Alpha is not known, v prime is also not known. So to solve this problem you require one more equation. How to get that equation, that we have to see. So keep that equation like that, and next go for the definition of E along common normal direction. So coefficient of restitution E is equal to V2 minus V1 by U1 minus U2. Again as usual, second body is at rest, V2 0 minus what is V1. Initially this I have to take along common normal direction. Initially body is moving downwards, but finally body is raising upwards as direction is changing. So the first body velocity after collision is v prime cos alpha. With sign if I take, it will become minus v prime cos alpha because direction is changing by u1. What is the velocity of the ball before collision? Before collision it is directed downwards. So its component was given as v cos theta minus the floor is at rest 0. Therefore if I take E is equal to v prime cos alpha by v cos theta. So I can write v prime cos alpha is equal to EV cos theta. This is equation 2. So like that, by applying law of conservation of linear momentum, I got one equation. By using the definition of E, I got one equation. Now if you see, I want the speed of this ball after reflection. That means I want v prime. If you observe equation 1 and 2, here v prime sin alpha is there, here v prime cos alpha is there. So squaring and adding 1 and 2, you will get the answer. So that is v prime sin alpha square plus v prime cos alpha square is equal to v square sin square theta plus here e square v square cos square theta you are having. So if you expand v1 square sin square alpha plus v1 square cos square alpha, sin square alpha plus cos square alpha is 1. So directly I can write v prime square is equal to, here if I take v square sin square theta plus e square cos square theta, but I want v1. So v1 is equal to v root sin square theta plus e square cos square theta. So the velocity after reflection v prime, sorry it is not v1, v prime. V prime is v root sin square theta plus e square cos square theta. If you look at the options, first option is the correct option as it is given v root sin square theta plus e square cos square theta. No other option is correct. Therefore first option is the correct answer. Now let us see the next problem, that is problem number 12 or question number 12. This is based on a spring concept. See the diagram and the problem. There is a block of mass m on a frictionless horizontal surface. There is a spring connected to the wall and it is going and colliding with that spring. So length of the spring was given, compressed length of the spring, and spring constant was given. What is the maximum momentum of the block after collision? So how do you solve this problem? If you take the diagram, here there is a spring connected like this. There is a block of mass m. Now it is going and colliding with the spring, and spring is compressed by length L. So what is kinetic energy of spring? As if you take kinetic energy of spring is equal to half kx square when spring constant given, x is compression or extension, given x is equal to L. Therefore Ke is equal to half KL square you can write. This is the kinetic energy imparted to the block. Now you want to calculate after collision with the spring kinetic energy is this much, half KL square, but you want to calculate maximum momentum of the block after collision. Then it gets released and pushes the block backwards, and thereby it acquires some velocity and it will have momentum. As you know kinetic energy, momentum you can calculate by this formula, K is equal to P square by 2m. So P will become root 2m Ke. As you know kinetic energy of the system, momentum you can calculate by this, P is equal to root 2, mass of the block is m, Kinetic energy was given as half KL square, and this if you simplify, 2 and 2 gets cancelled, and further if you write root mk, L square is L. Therefore, the momentum imparted to the block will be root mkl, and third option is the correct option, as in the third option you will find root mk into L. So third option is the correct answer.